Howdy, howdy, mathletes and math enthusiasts. We're going to start a brand new series of videos. Well, not brand new. We already did a contest in this set. But we're going to start a brand new contest in this video. We're going to do question number 1 from the Canadian Senior Mathematics Competition in the year 2012. Okay? So that's the senior contest, so we're thinking grade 11s, grade 12s, or very active 10th graders, 9th graders, 8th graders, if you're really sharp at math. But of course, for the younger grades, there's already a contest for you, the intermediate, in 9th and 10th grades. That's what that's aimed for. So, as I usually try and say, and often forget to say, try the contest beforehand. Go on to the link provided in the description, the Csmc website, past contests. You can get a copy of the Senior Mathematics Contest there, and you can try it for free. Try it, sit down with your calculator, programmable calculator, and give yourself a 2-hour time limit, set an egg timer or something, and try the contest before you watch these videos, because math is not a spectator sport. You cannot just sit there and learn math as effectively as if you try to do the math on your own. You can still learn by watching these videos, but you will not learn as much if you do not sit down and try. And this is something I did not realize for a number of years until sort of late high school. So you gotta try it. You really need to try them if you want to be the best. But all that said, let's take a look at the 2012 paper. This won't be a long video because all the Part A questions are very simple. Just write down final answer, and question number 1's as easy as they come on this contest. So, Part A, where we just need the final answer, figure A, B, C, D, E, and F, as we have over here, A, B, C, D, E, and F, has AB equals 8, and BC equals 15, so there's 8 and 15, and EF equals 5, as shown. So they have our picture of A, B, C, D, E, and F. So we have this weird figure, 1, 2, 3, 4, 5, 6. It's a hexagon of sorts. Determine the perimeter of A, B, C, D, E, and F. Alright. So noticing all these right angles here might be important. There's sort of 2 ways to do this. This problem. The first, which I will briefly mention before I actually solve it. So let's draw our picture. That's E, that one's F, A, B, C, D. So it's 15 down here, 8 over here, and 5 up here. So there's sort of 2 ways to do this. One, we can actually track things down and realize that with all these right angles, we can figure out all the other sides. Or what we could do is realize that A, B, C, D, E, F has the same perimeter, but not the same area, as this rectangle, which I guess we'll give them names P, Q, R, and S. $15, and then there's sort of a break here where it's 5 and 8. So it's 13 on this side, 15 on this side. Oh, that looks like Laz. No, it's Has. So how might we see this, just looking at the picture? Well, A and F, I mean, they're basically on the same line. So if we were to just sort of take EF and pull it all the way up here so that F and A matched together, and filled in the area, we'd have a side length of 13, a side length of 15, and this would be complete. As E is dragged over along with the line EF, we make a rectangle, and then we know that this is going to be 13, and the whole length here will be 15. We could see it the same way as if we dragged AF upwards by 5. Either or, you could complete it as a rectangle and sort of realize that the perimeters are the same. But if you didn't want to do that or didn't realize that, that's okay. That's okay. We all go at different speeds. What we can do is look at it another way. Okay, so second way, we can figure out all these lengths here. We can see the length of CD is the same as the length of AB added to the length of EF. And that's 8 plus 5, which is 13. So I'm going to redraw our picture over here, and we'll label it as we discover things. D, C, E, F, A, B. Okay. Oops. B. 15. Okay. So we know this is 13 now. We know this is 5. We know this is 8. Now AF and ED, we don't quite know what they are. That's a problem. But, and this is sort of the intermediate step of knowing how to get CD and knowing that the perimeter here is the same as the perimeter of PQRS. The intermediate step is realizing AF plus ED is equal to 15. We go to this length and we go straight up so we don't miss a beat, and then we continue on in this direction so we span the same distance as BC. Okay? If we wanted to, we could probably introduce some variable x and break this down into rectangles, but we don't need to. We don't need to. The perimeter is AB plus BC plus CD plus DE, which is the same as ED, plus EF plus FA. Well, that's equal to 8 plus 15 plus 13 that we just figured out up here, plus something, plus 5 plus AF. So if we add up the numbers that we do know, 8 plus 15 plus 13 plus 5, we get 41, plus ED plus AF. So that's 41 plus 15, which we just figured out here. So we can get a final answer of 56. And again, there's probably a third way where we break this up into rectangles and sort of really rigorously work all this out, but you don't need to with this question. Remember, the Part A questions, they're just final answer. Okay, we just need that final answer. We write explanation on our papers so that we can get part marks if we fudge up an arithmetic mistake. I write down, or I try and write down as full solutions as I think are necessary, here so that you can see my workings. I post these online so you can download them and read them as I'm going through them even. But remember, it's a part. You don't need a whole lot of explanation. You don't need to be having sort of this very rigorous page-and-a-half long geometric deduction of exactly what CD is as a length. You just need to sort of look at it, write down some explanation, convince yourself of the answer, and once you're confident with it, move on. That said, if all you do is question one and you get it right, that's still something. That's still something because every year someone doesn't get question one. Okay, so take your time, but if you're trying to go for a really good score, you have to learn where the marks are in the contest, where they aren't, and what needs to be done with absolute mathematical logic precision, and what can just be sort of argued in a certain way, or when you can say, we clearly need to. And that's part of the reason you should be watching these videos. Also part of the reason you should be trying the contests for yourself, to really get a sense of that, of where you should be saying, oh, it's clear here, or where you actually need to justify things. Because you can only learn so much from watching me. You have to get sort of your own feel as to how you like to prove things, because this is you guys writing the contest, not me. So that's about it. That's all I have to say. I think that's the most I've ever said about a Part A question. Frankly, 1A is usually fairly simple. But we got 56, and we had 2 different ways, and if you wanted to, you could probably find a third way to do it, but we don't need to. We can move on to question 2 for Part A, and that's exactly what we're going to do. So in the next video, we'll see the 2012 senior math paper question number 2 in Part A. So hopefully you guys will join me for that. And remember, try the contest. Really try the contest first.